do it down here? Okay. All right, so today we're looking at completing the square. We've already talked about solving quadratics by square rooting, which you can do when what is true? When b is 0. You can solve by factoring if it's a factorable trinomial. Not all trinomials can be factored. So we're actually looking at this example right now. We've got x squared plus 6x minus 8. Okay? The problem with this one, you should try and factor it because factoring is going to be much easier than any other method. All right? But there are no factors of -8 that add up to be 6. So we have a new method called completing the square. All right? So I'm going to walk you through some step-by-steps. We'll write them over at the side, and we'll do our work at the same time. Okay? So, how to. Step 1, we're going to move C to the other side. Move C to the other side.
What happens if it starts on the other side?
Oh, it doesn't matter. Then you just get to skip step 1. So, who's C in my case? -8. So I want to add that to the other side to move it. So I'm going to add 8 over here, add 8 over here. So I've got 8 equals x squared plus 6x. So far so good? No. Now we're going to do what's called completing the square. I'm going to make a perfect square trinomial. And this is where things are a little bit weird. What you want to do now, I'm going to... Can I add something to both sides of an equation and it's all right?
Yeah.
Yeah, you can do that. If you have an equation, as long as you add the same thing to both sides, you're not doing anything wrong. You're not violating any math rules. All right? So I want to add a number. I want to think about this number, and I want to get it on purpose so that this creates a perfect square trinomial. So watch what we do. We're going to look at b, and we want to take half the value of b. So in this case, b is... 6. So I want half of that.
3.
And then I want to square that number. 9. So I'm going to add 9 to both sides. And you'll see why in just a minute. Okay, so let's write that down. We want to take half of b and square it. When kids make mistakes on completing the square, it's because they forgot to square it. And square it, okay? Add that number to both sides. So far, I know it's weird, but we're okay? Okay. Now, if you look at your trinomial, if you've done everything right, this will always be a perfect square trinomial. What do I mean by that? Think about this. What are factors of 9 that add up to be 6? 3 and 3. They're always going to be exactly the same. So if I asked you to factor this side, wouldn't you get x plus 3 times x plus 3?
Yeah.
Every single time it's going to be the same two factors. It's not always going to be plus 3 and plus 3, of course. It's going to be whatever it is. But in this case, instead of writing x plus 3 twice, can I write it as x plus 3 squared? Right? Isn't that the same thing? Instead of writing x plus 3 times x plus 3, I'm just going to write it as x plus 3 squared. On the other side, let's just add 9 and 8 together, and I get 17. Okay? So now, let's write that in words. We're going to factor the trinomial. Yeah. On my desk by the post-it notes. Factor the trinomial. Let me know if I'm running off the screen. It will always, and this is, again, a nice thing about these things in math is that it self-checks you as you go. It will always be a perfect square. And we're going to write it as whatever your binomial is squared. So don't write it as x plus 3 times x plus 3. Write it as x plus 3 squared. Maybe you have a thought what I want to do now. Look at where I am. I've got 17 equals x plus 3 in parentheses squared. Anybody have any idea what my next step might be? Remember what I'm ultimately trying to get. I want to solve for x. I want to get x by itself. No thoughts? How do I undo squaring something? Yeah, why can't I take the square root of both sides? You can. Yeah, that's exactly what we're going to do. I'm going to take the square root of both sides. All right? The square root of 17. Now, I don't know that off the top of my head. I know it's going to be 4 point something. So you can either, use a calculator, get it as a decimal. However, you can just leave it as the square root of 17. That's fine. But what do I need to remember?
It's positive, negative.
Yes, positive and negative square root of 17. What do you think the square root of x plus 3 is? Squared, sorry. X plus 3 squared. What's the square root of that? X plus 3, right? Doesn't a square root and a squared, they cancel each other out. They're like opposite operations. So on this side, I just get x plus 3. All right, so let's write that down. Got to move down a little bit. Okay, so step 4, we're going to take the square root of both sides. Take the square root of each side. Don't forget positive and negative. And guess what? I'm almost done. X is almost by itself. What do I have to do to get x by itself now?
The minus 3.
I'm just going to minus 3 to the other side. Minus 3, minus 3. The way we write our answer, it's a little weird with this because I have this positive and negative 17. So the right way to write it, I put the negative 3 first, and then I have plus minus square root of 17.
And then once you get the square root of 17, you just
You can leave it. That's it. Yeah, you can leave it. Well, it depends on how. Well, that's a great question. If I was trying to graph it, I would change the square root of 17 into a decimal, and then I would do negative 3 plus that number and negative 3 minus that number to get my two separate. We might. So let's go ahead. Let's just say that you wanted to do this. So let's find out the square root of 17. We'll round to the nearest tenth. 4.1. So that gets me negative 3 plus and minus 4.1. So now I just do both of them. I do negative 3 plus 4.1, and then I do negative 3 minus 4.1. So what's negative 3 plus 4.1 going to get me? 1.1. And then what's negative 3 minus 4.1 going to get me?
7.1.
Careful. Negative 7.1. And we can put our answers in brackets because we're just listing. So let's write in words what we need. Take the square root of each side. Don't forget plus or minus. And then simplify square root. Or no, I'm sorry. Sorry. We have to get x by itself. Solve for x. I forgot that we hadn't written that down yet. Solve for x. Then simplify if needed. So if you were going to graph, you definitely want to turn these into decimals because I have no idea where on, if someone asked me to put a dot at negative 3 plus square root of 17 on a coordinate plane, I wouldn't know where that is until I turn it into a decimal.
But you would know it's between 4 and 5.
Right. So I could estimate, but you might as well just go ahead, turn it into a decimal, and then there are the two places where my parabola is going to cross the x-axis. Okay? All right.